Now we are having the 11th question in isometric projections and isometric views. This reads like this. Draw the isometric projection of a sphere of dia 50 mm resting on a plate of 60 mm square and thickness 20 mm. So just see, for previous question and this question I am asking you to draw isometric projection, not view. So what is isometric projection? The length, breadth and heights are reduced to 0.817 times. That is only the important thing. The angles and are same like as isometric view. That you need to understand. So first we have to draw the orthographic view for this. So how it will be there? There is a plate of 20 mm thickness. It is 20 mm. It is square of 60. Right? Then at the center the sphere is resting. Sphere in the sense some kind of circle that will be there. The dia of this circle is 50 mm. So from this point to this point, let us say this is O, it is 50 mm. This, we can write pi. Pi in the sense, pi 50 we can write, is a dia. Now this is the orthographic projection. For this we have to draw the isometric projection. Here once again I am telling you isometric projection we have to draw it, not isometric view. That means the dimensions are reducing. So how much we have to draw it? The square how we have to do it? The square how we have to do it is draw some reference line. First construct this plate. Plate of thickness 20. So when the plate is there like this, so this is the one side I am taking 30-degree line. So this is another side 30-degree line. What is the length? Length is equivalent to the square size, 60. But here we are asking about isometric projection. So how much we have to take? 60 into point, I am writing this side like this, 0.817 times of 60. Whatever the value we are getting, the value you take it on this line, on 30-degree line, because it is isometric projection. Here also you take it 60 into 0.817 times. Let us say I am getting the point somewhere here. Likewise, you construct the plate. The height is 0.817 times of 20. Whatever the value that is getting, take the height. So this is 0.817 times of 20. This is 0.817 of 60. This is 0.817 times of 60. Then the plate how we are getting, whatever the height we are getting here, you draw the height here. You draw the height here, same height. You construct this plate like as this. Plate like as this. So this line, whatever we are going to have, parallel to this line. Same length. This length is parallel to this line. You are getting this length now. You put the point here, the same length, and you join these 2 points. Likewise, we are going to have the plate. So, of course, it is isometric projection. When you are representing the dimensions, you write it 60 only. No need to say this 0.87 times of 60 like that. But of course, its value is 0.87 times of 60. But when you are representing its original dimensions only, we have to represent. It is 20. Of course, its value is 0.87 times of 20. Then you identify the center point here. You join these 2 points. You are getting this. You join the 2 points. You get this is the center. Now from here, sphere. What is the iso radius of sphere? It is radius is 25 because diameter is 50, radius is 25. Right? So take the radius, iso radius. Iso radius in the sense, I am writing iso radius. Isometric radius is 0.817 times of 25. Whatever the value we are getting, measure from here. So let us say this value is somewhere here. I'm thinking of this. Let us say this is O. This is O1. Right? Now this value is this value. Iso radius 0.817 times of 25. So with this radius you identify this point. This distance we know it, I am telling you once again, it is iso radius, or otherwise we can write iso radius. This value is 0.817 times of 25. Now, actually the sphere is appear as full sphere only. It is not looking as reduced dimension, particularly the sphere. That we need to understand. Even though in isometric projection, it is appearing as a full sphere. The sphere is appearing as full sphere. So what we have to do after getting this point, you take original radius. What is the original radius? 25. You take 25. So you have the, with compass, draw the arc. This is the center. Draw the arc like this. You are getting the sphere like this. Actually, we are taking the radius from O to O1 as iso radius of this 25. But when we are drawing the circle, we have to use full radius. Even though it is isometric projection, the sphere is appearing as sphere only. That's why we have to show like as that. This is important question. You just mark it dark, these portions. This you mark it iso radius. This is iso radius. This radius is original radius, or otherwise mark it 25. Please feel that it is very important question. They will ask sometimes. They will ask this text, or otherwise sometimes they represent only this diagram and ask you to draw this. Thank you.
Go.
This is question number 12 in the series in isometric projections and views. So this question they are going to give like this. I am explaining one reference question or example question. Many other questions we can do in the same procedure. So you see the question here, how it is there. Here they are asking you to draw orthographic projection, orthographic view, not projection actually, orthographic view they are asking. This is isometric projection, isometric view. This is isometric view. They are asking you to draw in orthographic view. Just see. Here it in isometric view, come here, isometric view. Now we have to convert to orthographic view. This kind of questions only they will ask sometimes. See, I am not asking about the projection, I am asking about the view. That means the dimensions are same. See here, once again in the question, this is the length 75, this is the breadth 50, and see when you are seeing this component, the thickness is 12, this plate of 12, and on that we are having some kind of projection of 25, and it is having some kind of slant edge like that, and the same plate we are having some kind of cutting here. The same thing we have to represent in isometric projection. So when we are coming to isometric projection, just see, this indicates, this arrow indicates this is a front view. That means we are seeing from this direction. Our eyes are there from here, and this is what is visible when we are seeing from front. This is visible. When you are seeing in front, this front is visible. This entire front is visible. This is front view. If it is the front view, then what about the top view? Top view is this, and the side view is this. This is the front view, this is the side view, right? This is the top view. See here, I am drawing the reference line here, XY line. Here, vertical plane, horizontal plane. So, once again coming to the question, see here in this question, this is the front view, this is the top view. This side is visible, this side is visible. What is this side? Left side of the component. This left side of the component, we have to draw the right side of the front view. That means, very roughly I will explain here. If it is the front view, it is the top view we have to write at the bottom, front view above front view, below top view. The side view you have to write either left side or right side depending upon the component that is given. So see here once again by going to the question, here the left side of the side view is visible. If it is the front view, it is the side view, if it is the front view, top view and side view. This side, left side is visible. When left side is visible, we have to draw the right side of the component, right side of the front view. See here. That means here we have to draw the side view. Why we are choosing here? Because here left side is visible clearly, right side only we have to do it. Go to the question once again. If you see here, if this side is visible, other side we have to do it. This side, back side is not visible here. So that side we are doing that side. Likewise this. We coming over here. Then front view you have to draw here, top view at the bottom, side view we have to draw in this particular problem. Right side of the front view you have to do it. Now coming to this overall question, it is XY line. Then what is visible in front view? See once again the question. In front view when you are seeing in front view, this is always they are indicating. Once if sometimes in examination he is ignoring this, you can assume the front view either any direction, this direction or this direction. But generally they will show this arrow which is indicating the front view direction. Front view direction in the sense our eyesight. So when you are seeing in front, you just see it is a plate is resting on horizontal plane. This thickness is visible. What is the thickness, Amma? 12 thickness is visible. This 12 thickness, what is the 12 thickness? What is the length we have to take? 75. You draw in front view. Focusing front view, you have to draw this side. Then side view, you have to focus on this side like this. So it is a 12 thickness, we have to do it. But the length is equivalent to 75. Draw it 75, like as this. Then see here in front view, there is a 25, after 25 there is a break here. After 25 there is a break. And once again we are having here one more 25. So here some kind of groove will be there. This is the groove portion. Once again we have 25. Then we can say 25, 25 and 25. Then see here, when we are seeing in front view, this height is visible. What is this height, Amma? What is this height? Height 25. That means the height will be there from here 25. From this side this is 25. From here it is 25. Please see here it is 25. And from here 25, see in the diagram, we are coming straightly. What is this, Amma? It is line parallel to this. It is the length of 20. Come line 20 like this. Right, Amma? It is 20. Right. Now, how you have to write? When you are seeing from top, this is visible as a slant. This slant is falling at the distance of 20 from this edge. That means see here, from here measure 20, somewhere here, it is 20. Now how you have to join this point with this point? Slant. This is how it is visible in front view. No need to show it is a front view, because when you are drawing like this, it is going to be a front view above XY line. Now coming to top view, you extend the projections like this, This with 2h you do it initially. Now you can start somewhere, anywhere, this distance or this distance, whatever it is, I am taking from here. What is the thickness? Thickness is equal, width is equivalent to 50. It is 50 now. You take 50 here, this is 50 here, right. This is the like as plate that is visible. Now see here, the cutting is visible from top. When you are seeing from top, this cutting is visible. This cutting portion is visible. See, where it is there, we extend it with 2h lines, very light lines. What is the width of this one? See here, 12. You come 12 here, you take 12, you just have this. This is visible like as this. Then, top view, when you are seeing this portion, this top view is also visible. That how you can get it? You extend the line here. Show me here, please. You extend the lines here. What is the width here? The width is here. Show me here, Amma, please. The width is equivalent to 25. You just have 25 this. This is 25. So this is how long it will be there? Entire length it will be there, because this will be there the entire length. But you can observe that at this portion seems to be some kind of projection will be there. You just come like this, you make it like this. This is how we are going to see in top view. One more thing, I am sorry, this will not be appearing because nothing will be there here. You just rub it this. You just with the eraser rub this portion because there no line is visible here. Right, coming to side view. This side view, whatever that is visible when you are seeing it, we can draw the side view. From this side we have to do it. You can do like this. This is xy line. You draw one more x1, y1 line like this. x1, y1 line. Right? You extend the lines like this. Extend the lines like this. Extend the lines like this. Now, this is the extend the lines from here also from top view, here also from top view, here also from top view. Here. These are all 2H lines. Please, Amma, these are all 2H lines. These are all 2H lines. From this is the center, let us say O. This is the radius with compass, rotate it. This is the radius, rotate it like this. This is the radius, rotate it. 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 Then, how it is visible? By seeing this, you can understand that this, when you are coming over here, it is visible as a plate here. So, extend it, plate, plate. But above that, you just see, only this side portion only we are having, this portion only we are having projection. This portion only we are having projection. Extend it, this portion only we are having projection like as this. See here. Then what about this cutting portion? This cutting portion, when you are seeing inside, when you are seeing this side, we know there is a cutting here, but not seen when you are seeing it, because this is there inside. How you have to mark is, this one, how you have to mark is that this side have, see here, this portion we have to make the hidden line. This is enough when we are having full question. So this represents front view, this represents top view, this represents side view. So regarding the dimension, one place when you are indicating the dimensions, that is enough, because this is 75, no, this is already it is coming to 75. Regarding this 50, when you are coming in radius, it is also 50, no need to mark in fact. This is 25, once again 12, this is 12, 12 no, 12. So we are going to have this is 12 and this is 25, no need to mark. If you are mentioned here means same dimension, it is also coming over here. That is how we have to write the orthographic view of a given isometric view. My request is try to solve few questions like as this. If you are getting any doubt, please ask me so that I will explain you. Thank you.